Hi, and welcome to Perspective for Entertainment Design. My name is Polina Hristova, and I will be your instructor for the next 8 weeks. This class will be a beginner's class, and will mainly focus on the basics of perspective. We'll focus on 1-point perspective, 2-point perspective, 3-point perspective, ellipses, item drawings, plotting shadows, and SketchUp. Now, a little bit about myself. I graduated Art Center College of Design in Pasadena in 2009 with a Bachelor's of Science in Entertainment Design. I did an internship with Naughty Dog on Uncharted 2. Shortly after graduating, I did some freelance work for Sony San Diego on PlayStation Move Heroes. And after that, I got a job up at Lucasfilm Animation on the Clone Wars animated TV show. And now I'm an artist at Obsidian Entertainment on an unannounced project. But that's enough about me. Let's actually get on to the fun part. Now, today's class, we're going to go over some definitions, and we're going to go over transferring lines and points, and we're also going to go see some examples. So let's begin. Now, imagine a man standing against a translucent vertical plane, perpendicular to the ground. This plane will be called the picture plane. It's a plane in which our images and objects are projected upon. Now, directly across from the person's eye level is a horizontal line parallel to the ground plane that is called the eye level. It's also mostly commonly referred to as the horizon line. Now, on the eye level line, directly across from the viewer's eyes, is a point called the center of vision. This point is very important because it helps determine your perspective. In 1-point perspective, the vanishing point will directly line up with the center of vision. But the moment the vanishing point leaves the center of vision, it becomes a 2-point perspective. The moment you tilt the picture plane, it becomes a 3-point. Now, when doing a perspective setup, we need to know how far away our viewer is from the image plane. Now, our viewer doesn't necessarily have to be a human. It could be a creature, it could be an insect, it could be anything. It could just be even a camera. Now, normally when drawing for concepts, this point isn't as important anymore, but it is good to know for 2 reasons. It will help you find your cone of vision, which we will cover shortly, and it will help with measuring in this case. Now, I will teach measuring, even though it is a skill that normally isn't used anymore in the industry with programs such as Maya and SketchUp and any other 3D program. It's already figured out for you for block-ins. But it is good to know so you know how to draw a perfect cube for practice. So go ahead and draw a vertical line from your center of vision. Now, I have this in layers, so I apologize that all this information popped up. The distance in which your viewer is from the picture plane is called the distance line. If you rotate it directly 90 degrees, it is the distance line on your page to your station point. If you were to extend this line vertically, you will get your true height line, but this only works in 1-point and 2-point perspective. A true height line will let you take your vertical measurements, but we'll again cover this in the next class. The station point is very important because from here you will measure out your cone of vision. Now, the cone of vision is the area in which you can draw without distortion. It is generally considered to be an angle of 60 degrees, about 30 degrees from each side of the center of vision. Now, I will go over how to set this up as soon as we start measuring and 1-point perspective. But today I would like to go over the different types of perspective, some examples, and how to use reference points, which are also known as measuring points, and how to transfer lines. There are 4 perspective angles. The first one is one-point perspective. In one-point perspective, the verticals and horizontals are parallel to the picture plane. Now, it is important to know that lines parallel to the picture plane do not converge. Lines that are perpendicular or at any other angle, however, do go off into their own vanishing points. Now, in this case, the lines going in the depth lines are going towards their own vanishing point. Now, in one-point perspective, the vanishing point is the same as the center of vision. The next perspective angle is two-point parallel perspective. Now, it's important to know that in two-point perspective, the vanishing lines are about 90 degrees apart from one another. Now, in parallel perspective, that means that the vanishing points are equidistant from the center of vision, and that they're about 45 degrees angle at the station point. Now, the one thing you should know about two-point perspective is only the verticals are parallel to the picture plane, and therefore the verticals do not converge to their own vanishing point. However, the horizontal lines going to the left have their own vanishing point to the left, and the horizontals going to the right have their own separate vanishing point. The other example of a two-point perspective is angular perspective. Now, the vanishing points are still 90 degrees apart, however, they are not equidistant from the center of vision. The fourth type of perspective, and I apologize for this little error here. The fourth angular perspective is three-point perspective. In three-point perspective, there are no lines parallel to the picture plane, and therefore they do not converge to vanishing points. Now, in three-point perspective, it's generally viewed as you are staring at something extremely tall. Now, this could be a human staring at a really, really tall building, or they're a bird and they're flying over buildings, and they're having aerial views, or they're in a plane. Now, three-point perspective looking upwards is generally called worm's eye view, and three-point perspective looking downwards is generally referred to as bird's eye view. So here's an example of a one-point perspective. Here's another one. Now, in one-point perspective, I forgot if I've mentioned this, it is important to know that the center of vision does not necessarily have to be in the center of your page. It could actually be off to the side. Like in this example. Now let me show you some examples of two-point. Now, like we said before, in two-point perspective, only the verticals are parallel to the picture plane, and thus they are perfectly vertical. We are looking at the buildings from a corner as well. And now here are some three-point perspective examples. Here's some examples of perspective pieces I have done in school and at Naughty Dog. This is an Asian temple I did at school. It's an example of a two-point perspective. And here's another project I did for school, for a game project. It was my version of a sequel of Zelda. And here's one of the rooms to the temple. And this is three-point. Here's another three-point example. Same project. And here's a three-point example for Uncharted 2. Now, this doesn't look as extreme as the photos that I showed you, but this is also a three-point. Just further zoomed in, but we'll go over that. And here's some more examples of three-point perspective, and these are just like little building callouts. And here's a one-point perspective for Uncharted 2. Now let's get into some general concepts and rules, and finally start applying some of the things we learned today. So some important things to learn, to know, is the horizon line is always at the viewer's eye level. Well, not always, but most of the time. And it is very important to understand that the horizon line crosses every object at the same height. So let's put this horizon line at 5 feet. When we have a person that's about 6 feet tall, let's say his shoulder line crosses at 5 feet, the horizon line will always pass this person no matter how close and far away he is at the same point. If I had a box that is 5 feet tall, it too would stop at the horizon line at 5 feet. Now if the box was 6 feet tall, more of it would appear above the horizon line. Now what I'm doing here is measuring. Now I took the top measurement here and added 5 more because I said this box was going to be 6 feet tall, and so I know my horizon line is always at 5 feet, which means I have 1 foot up here. I know how long my box is in a 1-point perspective, or tall. Now let's do another demo about the horizon line. Now let's say we were trying to find the tallest pole out of a certain amount of poles. And we know what our horizon line is at. And in this case, we'll just say it's at 3 feet. And let's just draw a random size of poles. So how do we find out which one of these poles is taller? Well, we know that the horizon line crosses through every object at 3 feet. So we know that every distance underneath the horizon line is a 3-foot mark. So this will be just simply creating new layers and counting. Now I apologize, perspective is a pretty mathematical course. It's not very fun, but uh, it's a good skill to practice and learn because as we progress as artists, we get a lot faster. Now D, I don't have to measure because it just stops at the horizon line, so it's at 3 feet. And E is so far in the foreground that 6 feet just looks... So in this case, B is the tallest pole. So let's get into a little bit of one point and transferring points. Now, let's say we have line AB. And we want to move it over here. Now, if you draw a line from A through that point to the horizon line or eye level, we can call that a reference point. Now, if we wanted to find the line AB, we can draw two parallel lines. Now, what do we know about parallel lines? Well, parallel lines converge into a single vanishing point. In this case, we can treat our reference point as a vanishing point. Now, once we drew those, I drew the line from the point across, and that gives me the same distance of a line. So that gives me the same length. You can also do this vertically. Now, let's say we wanted this vertical line, and we'll call this CD, and we want it to move it over here. Now we have a new reference point. And now from the reference point to point C, and from the dot, we have our line, vertical line, which signifies the same length. Now what if I wanted to do something tricky and not have it so easily aligned? Or maybe I want to transfer 2 points even. Now let's transfer line EF to these 3 points. Well, it's very similar to the concept we learned here. Now we're just going to have to do more of it. So from point 1 through point E to the horizon line, and then back from that reference point to point F, and from that point draw another horizon, since we know again it's parallel to our picture plane. And that gives us our new line. And in this case, it looks like one of our points here almost lines up directly with that. But for the sake of this demo, let's actually draw another reference point. Back to line F, through, and that gives us the same length line, just further up. And now for the final dot, again, take it from one end of the line, through that point to the horizon, and back down to F from that reference point that we just found, and draw a horizontal line, and that gives us the length. We have now transferred line EF into 3 different points, at 3 different points. Now let's do something a little bit more complex, which would be transferring a box to a different point. So we'll have our vanishing point here. Now, all parallel lines converge to the same vanishing point. All parallel lines to the picture plane do not converge. I apologize for repeating it so many times, but it is a very important lesson to learn. So let's say we have this plane and we want to move this plane to this point. Well, like in reference points, we can transfer specific different distances using a reference point. Now we still want the rectangle to go into the same perspective, so we'll take those back to the vanishing point. And from the reference point to the back point, we'll draw another line. Oops, I missed a point. Now this distance and this distance are the same, which gives us the back of this box. We have now transferred the box, or sorry, the rectangle. I have a habit of saying boxes when it is not perfectly a box. It's just a plane that's not even a square. So how do we transfer this plane to this point? Well, same way, take a reference point. Now, I connected my corners a little too soon without explaining, so let me catch you guys up. I imagined this as line AB. Now, if you recall in the previous section, we found a reference point by drawing from the bottom of the line through the point to the horizon line. That gave us a reference point to the top. And that gives us the length of the height of our future line. Now, we know that parallel lines converge to the same point, so I drew from the point to our vanishing point. And that gives us the where it crosses the bottom of this line. It gives us the depth of our plane. So go ahead and just draw some vertical lines. And from our height line, draw back to the vanishing point, and go ahead and get rid of all that unnecessary stuff. I always like to draw my lines longer, so I make sure I don't miss it. And now we have the same plane further back. Now let's say we wanted to transfer a plane, but it had a dot or a hole in it. How would we do that? Well, it's always easy to break down complex objects into points and lines. So let's say this surface has a hole in it, a square-shaped hole, and we wanted to move this whole surface over here. How do we do that? Well, reference point. And in this case, I have to extend my horizon line a little. Go ahead and find your plane. So we know this distance. Go ahead and draw some verticals. Or draw your, if you want to draw perfect height, go ahead and draw it to the top point. Back to the vanishing point. Well, we found our plane, but how do we find this box over here? Well, go ahead and draw a vertical line to find where it starts. In depth. Transfer this distance back. Bring it up. Transfer the height. Transfer the bottom part of that hole. And now, for the horizontals, bring them back. Sorry. Oh wait, I was right. The horizontals, bring them back to the vanishing point. And now, find the length of that line by drawing back to the reference point, and draw a vertical. Now, I know this looks like a big mess, but we basically found our hole already, so let's clean it up. And I'm just going to desaturate the reds a little, just so you can see better. So that is your box with a hole. Sorry, that is your plane with a hole transferred. Let's just do a a plane sitting on the floor as well. Oops. Human error. And I'll just use the same vanishing point. This time I'm going to make an even more complex hole. Just clearing it up so you can see the shape. And now let's move it over here. Let's find a reference point. In this case, because I don't want to extend my canvas, I'm going to draw it crisscrossing over. Draw it back to the vanishing point. Now that you know the length of that line.